Hello, ladies and gentlemen, and welcome to the official channel of Alusus programming language. In this video, I'm gonna talk a little bit about or give an introduction about this language and what makes it so special. And I'm gonna focus on the basics in this video. I'm gonna explain a little bit about, what the most important differentiating factor about this language compared to, classical or standard languages out there. And then I'm going to get into building something with this language. So I'm going to focus on the basics, building some simple app. Before we start, for those who don't know Alusus programming language, Alusus is a new programming language that has one main special feature compared to standard language. It's a general purpose language, but it's also expandable. It's flexible. Flexible in the sense that you can actually expand the language by adding new grammar, defining new grammar of your own within your code. So you don't have to, install plugins or changing your build environment. It's just that within your code, you can import libraries that add the new grammar, or you can just actually write the code that add the new grammar within the same program that actually uses them. So that's one thing. And the other important feature or differentiating factor about this language is that it is more open. What that means is that within the compiler itself is open. It's not a black box compared to other languages. So within your code, you can actually reach out to the compiler and read information from the compiler, or direct the compiler to do things in a certain way. You can actually create code at runtime, and then have that code gets compiled and executed. I'm not gonna dive too deep into these advanced topics because, as I said, it's advanced, and in this video I want to focus on the basics first, which is just building something with the language. So, but if you need more information, you can actually refer to the official website, alusus.org, and then you can find all the information you need there. There's pretty enough documentation there. So before we start, one thing to keep in mind is that I'm going to use AI with building a simple example, and then I'm going to use Cloud Code. But one thing to note is that since the language is new, AI will not know much about the language. So when you use AI with such a new language, expect AI to make mistakes. Now, if you go to ChatGPT and ask it about the language, it will most likely know the language. I mean, it does know the language. Most likely, it will answer questions correctly if you ask it. If you ask it to write code, though, maybe simple codes, it can write simple codes, but I don't expect it to be able to write more sophisticated code without mistakes. So given this, one thing you need to do in order to get to make use of those AI tools is to tell it where to find documentation. So in order to do that, you can go to the documentation section. Obviously, there's all the documentation here for you to read, but you can also tell AI to read from these documentations as well. So within these, you can go to this document, which is AI assisted development. Click on that. You'll see some instructions on how to get Cloud Code to behave better or perform better when writing code using Alusus. So all you need to do is basically create a file called cloud.md and then put this content in it. I assume, or I expect, the same thing that can be done with other coding agents, but Cloud Code is what I have right now, so I'm going to try that one. So I have VS Code here. You can use any editor you want, but I have VS Code here. It's empty. I have a new project. I've already created a file called cloud.md, and I have copied all this code or this text here. So it's basically ready to start. So with this, let's go ahead and start coding something. So what are we going to code? We're going to code a simple to-do list application. So an application that just shows you a list of to-do items, and you can just add and remove from that list. So we're going to open Cloud Code. Let's make this a little bit smaller, and then let's ask it to do something simple first. So one thing to keep in mind is that AI works uh, AI works better when it has something in the project. When the project already has existing code, it performs better because it looks at your existing code and learns from it and follows the same patterns. So in this case, we have a completely empty project. So it's better to start step by step instead of asking it to build an entire application upfront. Otherwise, you're gonna if you tell it to build a lot of things with an empty project, you're gonna end up with a big project that has a lot of mistakes all over the place. So the better thing to do is to start step by step, and then with each step you correct it, and then AI will start behaving better and better. So I'm going to start with something very simple, which is I'm just going to tell it, write a page that displays the name of the app. The name of the app is to-dos. It's as simple as that. So let's see how it behaves. So if it, we'll see before we accept its changes, we'll see how close it is from a real Alusus app, and then if we see it not not good enough, we can tell it, we can give it some instructions. So it's doing some things correctly, but it's obviously it's too far from what Alusus app should actually look like. So I'm not going to accept this, and instead I'm going to tell it to read web. So web platform is the library that we use for analysis for full stack development. So I'm going to tell it to read web platform examples and follow similar patterns. A similar pattern. So this should help it perform much better because it's going to look at the examples and then it will learn from it. So it learns from examples apparently more than it learns from documentation. But we'll see how it performs after we allow it to read all these documentation and examples. Yes, go ahead. Yes. You can tell it yes and don't ask again, but I usually just like to see what it's reading, so I'm not going to say that. Okay, it says now it has enough information. Let's see what it writes for us. All right. Overall, this looks much better. Let's read through it and see what it's doing. So it's importing some standard libraries. It's importing the Alusus package manager, and it's needing that to load or import more libraries that are not part of the standard libraries but are available on GitHub. So in this case, it's importing Alusus web platform. It's fetching it directly from GitHub, and then it's telling it to use these two namespaces, and then it defined front end, and then a function that start the server. So let's see what the front end does. So the front end is simply just a function with any name, but it has to have the UI endpoint modifier. So it's telling it this function represents the UI endpoint at this route, and then this is the title of the endpoint. And then within the function, it's setting some styles on the window, which is basically on the body of the web page, and then it's setting the view, basically setting what will be displayed on the page. And then here we have the view contains a box. Inside the box, there's some styles being set, and then it's adding a child, one child, which is a text that says to do's, and it's setting some colors and other styles. And then at the end, it's running the event loop, and that should be it. And then here, starting the server, really it's just printing something and then telling it to start to build the server, and giving it the port, which is 8010, and then telling it not to use any caching right now, which is useful during development. So all that looks correct to me. I'm gonna accept it, and I'm gonna look at it. So let's see if all these styles are correct. Let's try to run it and see what we get. Alusus main. It actually got it all completely correct, which is surprising, but that's good. So nice. We have a page that says to do. All right, cool. So let's stop this and let's add something to it. So now that we have the project, let's add let's add okay, add a list of that shows some to-do items. So let's start by actually displaying a list and then getting that to look correct, and then we can add the functionality to add to this list. So add a list that shows some to-do items. Start with predefined hard-coded list of to-do items. So we'll start with that, and then we can add some user input for adding and removing to-do items. Okay, it defined to-do items, which is an array of strings, and then this has these. Okay, that looks correct. And then what else is doing? It's changing the justify to be start, and changing the padding. All that's good. Title, and then after. Okay, so it added title, or it changed the margin for the title, and then it added this list. Let's see what the list looks like. So it's a box, and inside the box there is add children, and then inside add children it's doing a closure. This is not exactly correct. I can explain to it how to do it correctly, but it might actually just be simpler to just change the code myself. So I'm just going to accept it and then fix it myself. So why is this not correct? Because the add children function or method doesn't really take a closure. I'm going to explain some of this syntax later on, but let's get it working first, and then go back and explain what all this syntax means. So instead of doing this, what it's doing here is that it's defining a box, and then what is it doing? So I would expect it to. Oh, okay. So this ends here. It says add children, gave it a closure to create a child, and then at the end it looped, or it thought it would be looping on all the items. It got completely confused, but let's fix that. So instead of doing this, we'll just define an integer and then loop through. So for I equals 0, okay, loop through all the items within to-do lists, and then in here for each of these items we do an add. We do add children, and then here what we do is we add a box, okay, and then set style, we set some styles for that box, and then within that box we add children, and then this says to do items of I, that's correct, and we set some styles, and then we don't need this. So at the end, this should be it. Okay, so style, here we added, it added a text here that just has a dot, and then added another text that shows the actual item. Why did it add it as two separate texts? Okay, that's fine. I just gave it different colors and font color and font size, so that's fine. Let's keep that as, and then run it and see what we get. Parser syntax error. I think I'm missing some parentheses, or so add children. Line 36. Actually, this should be comma, not semicolon. All right, more errors. Or actually, one more error, which is on line 46. It says provided arguments do not match signature. On line 64, that's because we need to add a a parentheses. Sorry, not a parenthesis, a bracket. I actually like to do it like this. Okay, this is now better. Let's see. Okay, this looks correct. Let's see what we get. Nice. That is pretty nice. Okay, cool. All right, so the next step is to make this list editable. So again, we're gonna go back to Claude and tell it, add a form that allows the user to add more to-do items. So while it works on this, let's go back and explain some of the things that we are seeing here. So this is we're doing a function here. We're defining an array. Now, one thing to keep in mind about Alusus is that the square bracket is actually used for templates, and there's a reason why we're using square bracket rather than angle brackets. So in Alusus, there is let's I'm gonna let it wait. Let's go complete the explanation and then go back to Claude and see what it's writing. So in Alusus differentiates between square brackets and parentheses. So parentheses are used for anything that is runtime, and then square brackets are used for anything that is compile time. So, and this is an important differentiation, an important thing to know about Alusus. Now, the reason why it's not using angle brackets for compile time arguments is because it's compile time arguments in Alusus can be sophisticated. Like you can actually have an argument that is an entire statement or a block of code. So it's using angle brackets is complicates the parsing first, and also can add confusion to people or a person who reads the code. So that's why it made it universal. Square brackets is always used for compile time arguments. Parentheses are always used for runtime arguments. So that's why when you look here, this might be confusing to some people. So here this is an array, and we're using the parentheses to access members of the array. So yeah, that's basically because this is an array. Accessing elements of this array is happening at runtime, so it uses parentheses, plain and simple. So in other words, like really an array, what's the difference between an array and a function? If you think about it, even from that perspective, an array is really just a function that has predefined, a map of what output will get for each input, and the input is just a set of integers. So really, you can think of an array as just a function that behaves in a certain way. And so it's from that perspective, it makes sense to use parentheses for arrays. But really, the main code, from Alusus perspective, is just because it's runtime, so it uses parentheses instead of square brackets. So that's the first thing to keep in mind. so what we're doing here is we're defining an array, which is a template, and we're giving it the type of the data type of that array, which is a string. So, and since um, solving the templates or executing the template happens actually at compile time. So the template is taken by the compiler, it gets executed, you can say executed or handled or processed, and that processing happens at compile time, and therefore the argument that is used during that processing has to be square brackets. So we're defining the array here, and then we're giving it parameters for the constructor, and then these parameters is just this list of strings. Now, when you give a list of things that like an undefined list or undefined number of items into, like when we pass that to a function or a constructor, you use these curly brackets. The curly brackets basically indicate that you're passing an undefined, or like what do you call it, like a variable list of arguments. So that's what we're doing here. We're just instantiating the array with these strings. And now here's the important thing to note here, which is this syntax, which is dot and then curly bracket. This syntax basically means you use this, whatever is before the dot is going to be used inside or used by default inside the curly bracket. So in this case, here what we're doing is really telling it this. So if we remove this, this is equivalent to the previous code. So instead of doing all this duplicating, we just use this notion, which is dot and then curly bracket. This has the benefit of obviously making the code shorter, but it has another benefit that is more important, which is it allows you to modify objects or objects before passing them over to functions or to other places. So in this case, you can see this here clearly. So we're doing set view of this window. We're instantiating a box. And then before we pass it over to the function, we are doing dot curly bracket, and then we're modifying it before we actually pass it to the set view function. So this allows us to build trees of objects without actually having to define a variable for each element of this tree. And so this makes it really, really useful for building UIs. So you'll see here, that's very clearly. So it's very clear here. So we're doing set view, we're doing a box, and then open this curly bracket, setting the styles. By default, this will apply to the box. And then we're doing add children. Again, this will run on this box. And then within the children, we're defining a text, and then doing the same. Open like dot curly bracket, and then we're doing style. Now this style applies to the text, and so on. And then here we're defining a box that automatically, and then all this, all this modifications happen before the object is passed to the function. In this case, the add children function. So here we're doing a box, we're setting the styles, and then now within the curly brackets, we're actually running code. Whatever you can write whatever code you want. So in here, what we're doing is we're setting the style, and then we're defining a local variable, and then we're doing a loop, and then within the loop doing add children, and then each of these we're doing the same thing, opening curly brackets. So you can see like we're building an entire UI using Alusus language itself. Without needing any things like JSX or JavaScript or XML or YAML or all of these like UI specific languages. We don't need any of that. We just use Alusus itself, and the code still looks readable and kind of similar to those UI specific languages. So we get basically 2-in-1, which is really, really nice. And on top of that, we can do things that we can't really easily do with JavaScript like XML or JSX. So here we actually within the curly bracket we can actually run code. So we're doing a loop here to create multiple of these elements. Now, if we want to do this with HTML, Obviously, you can't do that with HTML. You can't do loops within the HTML document. Even with something like JSX, like React, we can't do the same thing because JSX itself, again, doesn't have any concept of loops or if statements. So what people end up doing is opening a curly bracket and then basically switching mode from JSX back to JavaScript and then switching again back to JSX and so on. So it results in a bit of a complicated syntax. Whereas in this case, the syntax is very clear. You're still within the same syntax. You're not switching syntaxes here, but at the same time, you're getting all the benefits of the code available. You can actually define a variable. You can do loops. And then you can write your UI in a readable and clean way, like you would with a JSON or a YAML definition. So you really get the best of both worlds. So which is really cool. So with this introduction, let's go back to Claude and see what it's doing. So let's skip this for now and let's see what it's doing here. So add to do form. So it's putting the form up front before the list. So here we have the list, and then let's look at the form and then look at the rest. So in the form, it's defining a box. A box is really just a div. So a box with some styles, it's adding children, and you have input, which has a placeholder that says add new to do, okay, and then a button that says add, and then it's setting the styles, and then setting styles for hover and active, and then it's setting the on-click event, or handling the on-click event, giving it a closure. Some of these might okay. Well, let's see it working, and then we get back to explain what this closure is doing. So, but in general, it's checking if we have text. If we added some text, it adds it to the to-do items, and then it adds it to the container. So it's doing some duplication, but that's fine. So here really it duplicated the same code. So we can like split this into a function if we want, but this is the same code as this. So this is the code that actually adds a single item to the list. So what it's doing here is it's capturing the box. So here when we did a box, now within this box, as we said, we're just instantiating a temporary object. We're not defining it as a variable. So in order for it to be able to reach to it later on, it captured a copy of that, or an instance of that, or sorry, a reference to that box. And then where did that go? It defined it here as a shared ref. This is shared ref. So it defined the variable here, and then inside this, it captured a reference to this list, so it can actually later on add items to it. And then it defined the UI for entering data, and then here it used this reference that it captured earlier to add the children to it. Now, one thing to keep in mind here, in Alusus language, Alusus is really a low-level language. It's not like it's not like JavaScript. It looks high level just because of the flexibility of the grammar. So we can add things that makes it look high level, but in reality, it's actually a low-level language. So here, when we define the reference, if we don't tell the closure command how to capture that reference, it might capture it by copy. What that means is that it will get a copy of that within the body of the closure. It will get a copy of the initial value of these items, and that the initial value is basically captured at the time of the creation of the closure. So at the time of the creation of the closure, these references are actually null. because we haven't yet reached the point where we actually set the value for this. So at this point, if we capture it by value, then when we reach this point to try to add to this list, this will error out because this will be null. So instead, we need to tell it that I want this to be captured by reference. Now here, it did this sort of correctly for some of them. So here, it needed to capture this and then these two. So what it's doing is when in the closure, let's actually accept this so we can actually see the whole width, get the whole width of the. Let me just wait for it first to finish, and then I'll continue explanation. Just because I want to see the rest of the. Let's close this for now. I thought I asked it to close it. Okay. So here it's the syntax for closure is you first define how you want to capture some of the variables, and then you give it the inputs of the closure itself. So this is fine. This is defined by onClick. So onClick takes or accepts a widget and a payload, a reference to a widget and a reference to a payload, and that's fine. But here, because we're reaching these, we need to tell the closure command to capture these by reference. We want, once the reference is changed, we want that change to be reflected within the closure. So we tell it by ref to all of these. It should have done this instead of. I think it doesn't really know the exact syntax, so it just thought it can do all of them and then like list all the items and then tell it by reference for like to have this type or capture type applied to all of them, but you actually have to tell the capture type for each single one of them that you're capturing. So here I'm telling it to capture these three by reference and not by copy and not by value. So what are these three? So the to-do items is, this is the input. Where is that created? So the input is created here, and then we have the items themselves, and then we have the container. So it captures all those three. Where is that? It captures all those three by reference, and then here it can use them inside, and that should be good. So let's save this. Let's see if it works. Got some error. Provided arguments do not match signature on line 71. Flex should be flex 1, like that. And then so let's see if how that works. Okay, that looks good. Let's meet my friend. Let's see if it adds that. There you go. We got it added. So overall, I think Cloud Code is behaving better than I thought it would, which is cool. So the next step is to have this data be saved on the backend. So let's go back to Cloud and tell it to, did it just start a new, I think it started a new session, but that's fine. Okay, so I'll tell it change the code so that the list of to-dos is stored on the backend. And then the front end. So let's see what it does now. So it should start creating other endpoints. Okay, so first to do is to create a storage for to do using an array. So it's gonna, I guess, it's going to start with the to do items itself as an array being on the backend. So let's see what it did here. So backend storage, it just defined the array, and then backend endpoint, it defined the endpoint. This is the path for the endpoint. Now, so here we told the web platform that this function is a UI endpoint. And then here we tell that this is a backend endpoint. Now you might wonder what's the difference between, from the perspective of the library, what's the difference between a backend endpoint and a front-end endpoint? The main difference is that a front-end endpoint needs more than just this code. So behind the scenes, what Alusus web platform does is that it instructs the compiler to compile this function as WebAssembly. And so all of the code that you just saw is actually running in WebAssembly. So if you go here and you do like view code, it's really nothing. There's just a single function that tells it start and then gives it the WebAssembly file. So everything you're seeing is completely WebAssembly, which is again like one of the important features of web platform. So it's really cool. So in the case of a backend endpoint, it doesn't really need any of that extra boilerplate for having a UI running. It just needs to receive a connection and then respond to it. So it's simpler. Let's see what it does here. So it defined a backend endpoint. It told it this is a get endpoint and this is the path and this is the function. Now this is not correct because the function should receive a connection object and then it doesn't return anything. So I'm going to tell it that backend functions should receive argument. So backend function should receive argument and should not have a return value. So let's see with this hint if it can fix it. Okay, connection is a reference to a connection object. What did it do here? So connection set content type. It improved it a little bit. It still has mistakes, but that's fine. We can take a look at an example and then fix it ourselves. So I'm gonna just accept it for now. So in the meantime, let's go back to Alusus and go to libraries and take a look at an example. So if we go to web platform, we look within examples. Let's look at the chat example and see this backend endpoint. It's doing http.print. What is it doing here? Well, it's doing http.print, and the content type is really just doing it like that. It's pretty basic. So we'll fix it after we see what it's proposing here. So it's going to remove this from the front end, which is correct. We don't need it anymore. We're going to fetch that from the back end. I'm going to wait for it to finish before I make any changes to other functions. So what is it doing here? So it's it changed. Okay, so it removed this to do items. Yeah, which is correct. And then here it's sending things to the backend. It's using HTTP post. This is not correct. It should be okay. So I'm gonna tell it to. So it's doing things sort of half correct. So it's sending us a request to the backend and then it's passing a closure. And once this request completes, it's doing this existing thing. So it's almost correct, except that this is not correct, http.post. So I'm gonna tell it to http.post is not the right way to make requests from the front end. I'm going to tell it to just look at the chat example. Or should I just tell it send request? I'm going to just use the send request function instead. So this should be enough hint for it to go and look either within the documentation or look in one of the examples, like the chat example we were looking at. Okay, let's see. So this is the first line is the same. Here it's doing send request, it's telling it it's a post. This is the path, new to do, and then it should give us the okay, it's still not doing it correctly. It's supposed to be first. It's supposed to give it the headers and the timeout, and second, the closure should receive a JSON and not a string. So, but since it's doing multiple mistakes, it's going to be easier to just fix it ourselves. So I'm going to tell to continue. All right, and now it's removing all this. Why is it doing that? It didn't yet add. Okay, I suppose after it removes it, it will make a call to the backend to fetch the to-do. So I'm gonna say yes. Okay, so at the end it did send request, get to-dos, okay, and then it gave it a closure, and then within this it parse array. This is not correct, but we'll fix that. And then it's doing a loop on this array, and then adding this is the same code as it was before, so this is all correct. So there are some mistakes about how to deal with the response, but let's accept it for now. Okay, so let me close this so we can have the full width. So let's fix things one by one. So first of all, we need to do, let's look at here at the example we have. So we need to do http.print instead. So here, let's just copy this as is and then modify it. So, what is this? I don't know what is that. Some new feature of VS Code. Okay, so what is the response? Is actually called result. So we don't need these, and we tell it result. Okay, and I don't know what this is. Is that's probably Copilot. But anyway, so this is the get endpoint. It's starting with an array, so it's doing a JSON syntax basically. So that looks good. And then here in the post, what is it doing? This is again not the right way. Let's look at this post. I'm starting to hate this thing it's adding. So anyway, so post data, we're giving it some initial length, and we're telling it to reading that length from the connection. And now, why is it checking? Okay, so I guess we can say if post data size greater than 0. So I think we can say if it's not greater than 0, we'll just return our 400. And then if it's greater than 0, we have something that's entered, then we'll just add it to the list. So we can just say we convert it to a string, and we return 200. Actually, 201, because we added an item. And then we remove this. So this is correct. And now let's go back to this, and let's again look at send request. So it takes, so the third argument is HTTP headers, and in this case we're doing a get. We don't actually, it's passing an empty headers, which is correct. What is the fourth argument is the data. So actually we can just tell 0, don't pass any headers, don't pass any data, and then give it a timeline, sorry, timeout. Let's give it 10 seconds as a timeout, and then closure. And then this is going to be JSON. Yeah. So now what we want to do is we're going to, instead of doing this, we're going to say define to-dos is a JSON, and that is equal to so JSON, and then we tell it event data. Is that what it's doing here? Trying to see if I have an example. Okay, that's fine. We don't really. Oh, on fetch. Let's see what we're doing on fetch. On fetch. So yeah, JSON event data, and let's just copy this. So this gets the event data. Sorry, this gets the body, and let's convert that body to JSON by. So this will result in parsing it, and then here we do a get length. We loop on all of the items within the to-dos, and then we're doing all this correctly. Sorry, to-dos. Yeah. So that should do it. And then let's save this. There is another place where it's doing the send request incorrectly. Let's fix that. So 0 headers. No, actually not 0. String. That's content type. Application text. And then new to do. The to do is just text itself, and then we tell it, we give it 10,000 as 10 seconds as a timeout. Let's bring this to a new line because it's becoming fairly long. Okay, that should be it. Is there any other send request that's doing incorrectly? That should be it. Let's give that a try. And let's see what happens. Provided arguments do not match signature. This is happening in web platform. I bet you it's something to do with the BE endpoint. Let's see how it's done here. I can't see a mistake myself, but let's compare. So BE endpoint. Oh, okay. So the connection is a pointer, not a reference. So this should be a pointer. That's why it didn't match the signature. Okay, unknown symbol at line 40. That's because stupid Copilot added something that we don't need. Okay, and then on line 42 it says provided arguments do not match signature. So to do items is an array of strings. If we do post data, so post data is an array, we actually want the pointer to that array, so we tell it to give us the pointer. Whoa, what is that? Looks like this is a bug in the compiler itself. It's okay. Well, I am guessing this is so. There's some error in our code, but there's a bug in the compiler that's preventing it from showing us a meaningful error message, and that actually is this. We need to have an and sign between the actual arguments of the closure and the capture definitions, like the closure argument or the closure data capture definitions. So we need and between these, and then this should be a JSON, not a string. And let's look at the other one, see if it's, again, it needs an and here. And let's see. Okay, this looks better. Reload. Okay. I got, let's add our same to do, which is meet a friend. Okay, something is, so it got added, but something was missing. So let's see first of all if it actually added something at the backend. So let's do a refresh. Okay, so after refreshing, I got this. So the data did actually go to the backend, but it, as soon as you actually click it, we missed the actual. We were able to send the data to the backend, but we were not able to correctly display it immediately. Why is that? What are we doing here? So new to do. So we're capturing that to do here. Oh, okay. So actually here we don't need to capture to do by reference. We instead, let's give that a try. So because we only need actually the value of the string. We don't need a reference to this variable, because this variable actually so this closure will run after the request is complete, and at that point this local variable will no longer exist. So we should get a copy of it and not a reference. So that should fix it. And now if we tell it meet a friend, now it works. And if I refresh, I should still have this. So there you have it. We have a complete to-do that is backend driven. There's still a lot of things to fix, but I don't want to make this video very long. So I'll stick to this. We can have a follow-up. I'll have a follow-up video to complete this. So things that are still missing. First of all, these to-do items. So we need to either do a lock when we access this, because this is a global variable. And if you don't know, Alusus language is a multi-threaded language, and a web platform is also multi-threaded, which means these can run in separate threads. So multiple calls to this can happen in parallel, and all of these calls are accessing to-do items. So this, we need some synchronization around this. So that's the first thing. And then the other thing so we either need to add synchronization, or better, we need to actually put this in a database instead of in local memory. So I'll do that in a separate video. We'll do this, and we'll move this to a database, and we'll also improve the app by adding a delete functionality, or maybe also edit, so that it's more complete. So before we finish the video, let's see if there's anything that I missed in terms of explaining what's going on. I think we've pretty much covered everything. I don't want to go very deeply, because you can find all that information in the documentation or in other articles online. But one thing that I want to kind of mention here or highlight is, well, two things. First of all, you can see here there is a little bit more complexity here when compared to other high-level languages like for example, JavaScript. So closures in JavaScript, you don't really need to worry about this concept of capture by reference or capture by value. So this is really a feature of a lower-level language. We have to actually instruct the compiler how to treat the data. So while this adds a little bit more complexity on you as a developer, it adds, or it improves the performance marginally. And I'll have a separate video to show the performance or comparison of the performance of Alusus and JavaScript. So a little bit of extra complexity in return for a much better performance is really worth it. The other thing to keep in mind, which is really interesting for anything who haven't seen Alusus before, is that this closure command, this is actually not a built-in command in Alusus. This is a command that was added by a library. So here you can see what makes Alusus special. So this closure command, we added it's a library written completely in Alusus. It's a single file. You can actually go online. You'll see the code. You can just look within the repo of Alusus. Just look for a file called closure.alusus. You'll find it. You'll find the full code. But using Alusus, we're within the same context of the running app. We're adding new grammar, which defines closures, and this is not just adding, a new syntax that gets translated to a different thing. It actually, when the closure is encountered during compilation, it runs actual code that actually, scans through your code base to look for things. So in this case, it's automatically looking for new to do. So this item is defined outside of the closure, but it automatically is finding it for you, and it's doing a capture for that, capturing a copy of it, and then where it's reading this, also this definition, it's knowing that this is something that needs to be captured by reference. It's searching through the code base, it captures that and packages it with the closure. So these kind of functionality, this is really not just a matter of a macro. A macro will not be able to do that, or any simple syntax. There's quite a few languages that allows you to define basic syntax, but really none of them I've seen that allows you to do this level of defining a syntax that actually, like when that syntax is encountered, the code has access to your full code base, can scan through the code base, look for things, and add a new code, and etc. So this ends up being, as I said, read all the data that's needed, creates a class for that data, packages all the data in the class, or copies that data, sets that data in the class, and instantiate an object, set that data on that object, and then packages that within the closure. So as you know, the closure is, as you know, is basically a pointer to a function plus pointer to a data. So it does all that for you behind the scene, and without really you need to do anything special. So compare this to something like the C language, where it's also a low level language. It also doesn't have the concept of closures, and people have implemented libraries that does closures through macros. But take a look at closures here and closures in C, and you'll see the vast difference and the really uh, amount of benefit this flexibility in the language, in the Alusus language, is giving us. And really, the possibilities are endless for what cool things you can do with this. But that's it for this video. I'll end here, and as I said, I'll write or I'll make new videos with more details. With whether it's related to this specific example or to other areas of Alusus language. So make sure to subscribe to the channel if you want to receive those videos. And with this, I'll end. And thanks for listening, and wish to see you again in the next video. Thank you.